In this case, we'll be hearing about the spectrograph architecture and hardware.
Seems like I was just here.
You were.
I were. Thank you. Okay. Well, we're going to talk about some other spectrograph hardware other than the FSX that produced many of those really nice images from Jupiter and the Sun that we saw. By the way, there is an FSX spectrograph running up in the Drake Lounge in case you haven't had a chance to pass by and admire it. And speaking of the FSX spectrograph, I wanted to just say a couple more words about it, and that's what it looks like. There's an analog portion and a digital portion. I guess the digital and the red is separated. And we talked about this before, but there's a microprocessor that controls the direct digital synthesis oscillator that feeds the signal in here and basically steps the radio through all the frequencies. And there's a 12-bit analog to digital converter that develops the digital data from it, which gets processed using Jim Sky's RSS software. Here are the guts of an FSX. A lot of parts, a lot of filters, coils. So this is the front end. This is the microcontroller, the direct digital synthesis oscillator is a plug-in card. The intermediate frequency amplifier with monolithic crystal filtering, and the detector. So that's basically what's inside the metal boxes that are used, and the metal boxes keep it sealed up pretty well and keep it from generating a bunch of RF noise that gets out, and the parts inside from getting polluted with a bunch of signals and noise running around on the outside. Okay, into the future. I guess you all have probably bought your $15 dongle out in the lobby there. There's a lot of new hardware that's available now. And of course, the ultimate goal, I guess, is to hook your computer directly to your anti-array. And it's conceivable that the analog wizard here will follow the path of the dinosaur in the relatively near future. I know I'm getting pretty close to that point myself. So there are several so-called software-defined radios available, and this is just a small sampling of them, but one of the earlier ones was the Soft Rock series. It's connected through a USB to the computer and generates 190 kilohertz wide spectrum. The FUNcube Dongle Pro Plus, which is a mouthful, kind of has the same thing on the output. And we have a couple of offerings from the company called RF Space. One's the SDR IQ, the other is the SDR 14. I think you've heard the SDR 14 mentioned a few times, and we'll talk a little bit about each one of these. And then we have the RTL-SDR dongle. I have no idea why I didn't come up with a better name for the thing. And then, of course, you've all heard 3 talks on raster, and that I'm not going to get into, but it's certainly an important entry into the area of software-defined radios. The FUNcube Dongle Pro Plus was developed by AMSAT UK for use in a student satellite project, and this software is called SDR Sharp. This is the whole radio. You might want to compare that to the FSX box, which was slightly larger. And the yellow bands on here are Jupiter, as recorded using our antenna at Woodward Community College. So, but this is a pretty narrow look at what's going on. It's only 190 kilohertz wide, and I have to do that once per talk, at least. And the record is about 15 seconds in length. There are 3 chips inside the FUNcube dongle. There's a filter, a bunch of filters, a tuner, a digitally controlled tuner, and a sound card and a microcontroller, and this communicates with a PC. One of the good things about it is that the tuning range, it goes from 150 kilohertz to 240 megahertz, and then from 420 up to 1.9 gigahertz, and has a very respectable noise figure across that band. Working in the high frequency end of the spectrum is tough. There are a lot of strong signals, and this is I'm not going to go through all these, but these are all the filters, band-pass filters that are used in the HF part of the spectrum to keep this thing from overloading. There's 13, I think there are 13 gallium arsenide switches in there that are switched in automatically depending on what part of the band you're listening to. And all those filters go in front of the tuner. So it was quite an extensive development project. Another box is the SDR IQ. I'm not going to go through this whole thing, but again, I want to point out that there's quite a bit of bandpass filtering required in the front end to handle overload and strong signals in the HF part of the spectrum. And again, the SDR IQ can only give you 190 kilohertz of bandwidth. Here's a spectrogram taken with an FSX machine, 15 minutes by 9 megahertz. This little bitty circle here represents this whole spectrogram taken with an SDR IQ. I really, sorry, I didn't do justice to the SDR IQ. The image is pretty washed out, but it's certainly capable of producing a very nice image, but only over a very small part of the spectrum. Here's a solar burst that David Hayworth recorded using an SDR IQ. So there you get a nice strong solar burst. It looks pretty decent on this, but you can't track it very far. It's only a 160 kilohertz wide spectrum. The SDR14 is a little more capable device. Here we have a 6 megahertz spectrogram and a 1 minute run, and we see some Jupiter activity in here in stations. This looks more and more like the FSX machine. Here's a train of S bursts recorded with the same instrument. Unfortunately, these are no longer produced. They're available on eBay occasionally. The replacement for it, Dave, is a white SDR IP, and that runs about $1,600. But this tunes all the way up to 30 megahertz, so you can get a nice chunk of the spectrum anywhere up to 30 megahertz. Again, a block diagram that I'm not going to go through. Okay, and then we have the RTL-SDR dongles. Tunes from 24 to 1800 megahertz. Got 2 chips, one there, USB connector, antenna connector. That's the whole thing. These were developed for digital television. And it's an interesting challenge. You know, we built the Jove receiver knowing what the characteristics were we wanted to build into the receiver. With these things, we're trying to figure out what's built into them to see if we can use it. And it's kind of interesting, you know, reverse or understanding it so that you can know what kind of physics it's doing for you. You know, if it's rewriting some science that you don't want rewritten by the way it processes signals. So we're trying to be a little bit cautious as we start to use these. They offer some interesting advantages to the narrower bandwidth dongles. These will produce a spectrum of about 2 megahertz wide. Again, it's just a tuner, depending on the tuner, I guess some of them go from 50 megs up to 1800 and some go down as low as 24. Unfortunately, I'm not aware, at least, of any of the tuner chips that go down below 24 megahertz. So it's tantalizingly close to where Jove is operating, but it's not quite there. And here's a solar burst that was recorded again by David Hayworth using an RTL-SDR. So if you're going to operate around 20 megahertz, you have to use an up converter, and there's Hammett up converter. It's available for $44, I think it is now. And that takes the HF band and shifts it up into the frequency range that the dongle can tune with the digital tuner chip that's in there. And I guess you can get it packaged with a dongle, and you can get it in the form of a kit. I got one about 2 days before I left on this trip, and I didn't have too much time to play with it. It does have, one thing I noticed immediately was that this has 10 dB of loss between the input and the output. So whether or not that's a real problem, I'm not sure. But generally, you like to at least not lose too much signal before you get to look at it. So the maximum useful HF spectrograph range, and by that I mean, something above 15 megahertz up to 30 megahertz, which we consider to be useful for looking at Jupiter anyway. So we've got the SDR IQ and the FUNcube Dongle Pro Plus producing a spectrum about 190 kilohertz wide. We've got the RTL-SDR plus an up converter giving you a spectrum of about 2.5 megahertz. And then we've got the FSX machine and the SDR14 generating a spectrum that can be up to 15 megahertz or so wide. Raster, I'm not sure where raster fits in this, but you're trying to tell me I got 5 minutes? All right. I thought that was a high five instead of a slap on the back of the head. It appears that raster is capable of, I think I heard the number 28 megahertz, producing a spectrum 28 megahertz wide, but I'm not really sure. So you'll have to apply whatever you learned during the SDR or the raster talks to this graph. There are two pieces of software that I'm familiar with vaguely, at any rate, and that's the SDR Sharp, which I think is used by quite a few folks, and then there's HD SDR. Now, the software was not developed for radio astronomy. It will demodulate different signals. It gives you a waterfall display, but it just doesn't play like Jim Sky's RSS software that we use with the FSX Spectrograph. I think there's a lot of potential in these inexpensive dongles, but I think the key to realizing it is in the software. And when it comes to software, it's time for me to get off the podium here and let Jim Sky come up and do some talking. So.
A little bit of setup. Yeah, go with the laptop. Okay. All right. Oh, we have to use a mic. Okay. Let me see. Let me get mine. Let's run this one. Be nice to do this at the beginning with. All right. I want to first mention that the Radio Sky Spectrograph software was developed under grants, another one of those DDF grants back in about 2001 or 2002, and they actually supported a couple of upgrades. After that, we can thank NASA for that. It's been wonderful to be able to produce a free software and for people to use. As Dick was kind of saying, that when you have a spectrograph for radio astronomy, or at least the part of radio astronomy that we're interested in the HF region, Jupiter and solar and that kind of thing, you want to have certain time, a certain time dimension that you want to work in. and frequency span that you're going to be interested in. You'd like for it to be displayed a certain way, be able to access the data on the screen to make measurements and that kind of thing. So we feel like RSS fulfills at least some of those requirements. Just like radio skypipe, RSS can be shared online real time. There's usually 4 or 5 servers out there. Now there is a glitch in my software that publishes when the servers are available, and it happened when I moved from one a web host to another, and so that's not been fixed. But so just keep trying. If you open it up and there's only one or no servers, wait a second, wait a couple of minutes, hit it again. Eventually you'll see a whole list of servers out there. Now how many people do we have? There's like 6 now, or I think there's like 6 available from Hawaii to Florida. We have pretty good coverage there. The data size is also important. We can't save all of this raw data. You have to reduce it to some extent, or you've got petabytes of data in a very short period of time. So you've got to reduce it in real time, and that's what we do. We take the RF signal and we just average it in little bins, and we save that. It's still quite high. If you Dave, how much is a day's worth? Is about 300 or 400? 320 meg. So one of these things running all day is going to produce a file about 320 megs big, and that's greatly reduced from the data that the thing processed. Also, I wanted to have a program that I could integrate with the other programs, Radio SkyPipe and Radio Jupiter Pro, and there are some ways that these pieces of software is linked together. We can run from 100 to 512. I had to change this parameter to 512 recently. Can anybody think of a reason why? Power of 2. That's so we could do some experiments that we've been doing with the RTL dongle. It's possible to have up to 16 bits of data resolution fit in our data format. We're only using 10 or 12 just because that's what the software provides, or the hardware provides. We get approximately 10 sweeps per second. That turns out to be just perfect for seeing some kinds of features. And as you saw earlier, there are 2 screens. We'll see. Well, I don't know if I'll see as many here or not, but you did see earlier that there's an upper screen with a 1 minute time span and a bottom screen with a 10-minute time span. There are some other limitations here. There are no timestamps in the data. So what we're doing is we know the beginning time, the end time. We're assuming that most of this data is produced by crystal clock hardware, that the data rate stays constant. Now, I'm not sure that's always true because, we could lose a sweep here and there for some reason. So we do want to work towards timestamps, or at least occasional timestamps, to help the integrity of our data timestamping, or knowing when each sweep occurred. We only work under Windows, but I was greatly impressed when I saw someone using Radio Eyes on a Linux machine the other day, and that was wonderful. And thanks for that demonstration. And so it's possible that this might work under Wine. He was using a Wine, and it seemed to work flawlessly. Also RJP, right? The Radio Jupiter Pro. I'll hit this one more time, just in case anybody's missed what the difference is. Basically, this is a strip chart, and above it is a corresponding spectrograph. And this is basically what we have here are a whole bunch of strip charts piled up on top of each other. That's basically what a spectrogram is. It's just amplitude over time. And so this is just, if you just took one tiny slice, one channel out of the 200 that are represented here, you can make a script chart of it. And then actually you can do that. And after you're done with collecting your data, you could go through any particular channel and you can script chart that. It does work that way with radial sky pipe. Something that we also have, there's also a display where you can see this just like a standard spectrum analyzer output. And you turn this on. This is always running in the background, so it doesn't slow anything down. You don't miss any of your averaged 10-minute data when you turn it on. But if you just wanted to take that old-fashioned spectrum analyzer look at things, you can do that view. To use RJP, Radio Jupiter Pro, the scheduling software with this, you can create schedule files, and the Spectrograph software can read those and turn itself on at the correct time and save only when you think Jupiter is above the horizon, in your beam. However you set up the schedule files, RSS can respond to that and turn your machine on. So it could be an automated. I don't know, did you know that one year we did that at WCCRO? I ran the whole season like that, and it seemed to work just fine. The other thing you can use RJP for with this RSS software is you can send information regarding the CML and the elevation, all of those things that are available in RJP can be sent in real time to RSS, just like they can to radial sky pipe. And in that case, it shows up in the little banner above. It doesn't get printed right on the screen. I see here, I only had a couple of other things I wanted to show you. In review mode, this is actually, let's see, you can load the data file in such a way, I want to make sure I'm loading the right one, that you can simulate a real-time experience here. Actually, there's and so you can play it back in kind of a movie mode like that. Now let's get out of that. Load the same one. Now this is from Dave Topinski's observatory before he had his power line buzz fixed. And if you can see all those little fine lines that are going like this, I don't know if they show up on the screen or not, but that's all power line buzz. It doesn't look like that anymore. I guess you knocked some noggins together, didn't you? Okay. Just want to show you things, just very quickly how you use this. You can adjust the color offset. Basically, that lets you look at values in the file that are lower in amplitude. But you might have a background that you want to just get rid of, like nothing coming through is lower than some certain value. Well, you can maximize your visual dynamic range on here by getting rid of all of that stuff and starting out with your lowest amplitudes being the darkest or at the bottom of your color scale. You can do that. You can also just increase the gain that you can, so you can multiply the values that come in so that they reach higher on your color scale. And usually you play around with that to some extent. Now, I don't know if normalize works in this mode. Oh yeah, you can do it this way. So what you could do if you had a bunch of stations on here, it kind of works backwards because that was kind of a clear image. But you can actually subtract those out. It looks like we put some in, but that's just because of the nature of this file. But, so if there's one station in the middle of that, that could be subtracted out of your image. You have little controls here to move back and forth through the file. It's very similar to SkyPi. Let's see, is there anything else there? You can pull up a little voltmeter here and check the voltage at any frequency. That voltage is, I would say, uncalibrated at this point, but we'll come up with a way to do that. Okay, almost done. I think the last thing I'd like to show you is the chart info, which is very simple. So we want the metadata thing is very important. We have a kind of a simplistic interface on this, but please, if you ever get one of these things, and I'm hoping you will, make sure you get your metadata up to date on all of your files so there'll be some value to some professional observer someday. And I want to tell you just briefly, we've been experimenting with the RTL dongles, and it's working. I have it working, but the sensitivity is a little low, like down 50 dB. So we've got that little bug to work on. I think I may have come across a solution here. I can't wait to get home and try it, and I think I know what I'm doing wrong. But we can see, I can turn on a signal generator and move it around and see it sweep up and down the spectrum as it goes. So we've got the basic thing. I just got to fix that one little bug. I don't know when we'll be releasing that. I don't know. It's experimental until further notice. I'm happy for other people to experiment with it, but I won't know what you're seeing until we do some measurements and spend some time looking at these things. And then the real proof of the pudding will be when Jupiter comes back in the season. So thank you.
Hey, Jim? How do you denormalize?
You could denormalize just by changing the color gain, I guess. Oh, no, you can't. Let's see. Offset? Yes, offset. Change the color offset, and then that gets rid of the normalization. Any more questions? Okay.